My name is Juan Nava, and I'm going to be showing you how to create a simulation using Vehicle Spy. Some of the things I'm going to be covering today is messaging structure. I'm going to focus predominantly on CAN. However, the techniques I'm going to be showing you today do apply to CAN, LIN, and Ethernet. I do have a separate video of how to do this with LIN. I don't show you how to use this, how to create CRCs or how to do a checksum, but the same idea that we're going to be talking about here will be the same thing. Uh, I will show you how to create a setup from scratch, so a platform, and then create a setup. We're going to be creating a simulation using function blocks, and we're going to be using C code interface. Function blocks tends to be sort of the beginning, intermediate, and can be advanced as well. But generally, we don't teach how to use C code interface. So today I'm going to walk you through how to do that for CRC or checksum. With this, I'm also going to walk you through how to create a graphical panel. And in this, I'm also going to show you how to create a graphic to be able to kind of interact with. I do have videos on how to do that, but I thought it'd be kind of fun to add a little bit twist to this. So other hardware that you can use for this will vary based on what you're going to be using. It could be Fire 2s, it can be Red 2s. Gigastars, reality, what you're going to be using will be depending on what protocols you got to work with. If you're going to be working with automotive Ethernet, Rat Galaxy would be a really nice tool. It could also be Rat Gigastar. Gigastar does 100 base T1, but also does 1,000 base T1. It also supports CAN, CANFD, and LIN. So it really depends on what you need. You can always contact us so we can help you pick out the right tool. What kind of licensing you'll need for today's purpose? You'll need at least a Vehicle Spy Professional or Vehicle Spy Pro. Enterprise would be something you would need if you're going to be working with Ethernet. So if you want to be able to decode that. But for what I'm going to show you today, it will be just based on CAN. So professional will be sufficient. That would allow you to use function blocks, or use specifically the scripting, and it'll allow you to do C code interface. So for that, you would need at least that license. Now, let's talk a little bit about messaging structures. And the reason we kind of need to know that because we're going to be working with CRC, and I want you to understand what you're going to be looking at from a CRC perspective. So messaging usually has some kind of control field that may tell you what the message is. Could be arbitration IDs for like CAN, for example. In Ethernet, it would be things like the MAC address. It could be port numbers. So that could be part of sort of that part. Though in Ethernet, it's not called a control field, they're called something different. But ideally, if we kind of generalize it at the beginning, it tells you sort of what the message is all about. After that, you'll see something green, which is basically your data bytes, so your actual data that you're transferring, whether it's like vehicle speed, power moding, or any other piece of information. That's really your data bytes. And then you have a CRC. CRC is a cyclic redundancy check. And what that is basically it's used for determining if a message actually went through correctly. In other words, did the transmission go correctly? Now, this CRC is part of the normal communication. You'll see this in LIN. You'll see this in Ethernet as well. And it's just, again, to know that the message did, in fact, get received correctly. In other words, did the transmission go correctly? The part I'm going to be showing you today is a CRC that actually goes part of the data bytes. So this will actually be inside the green part. So it's actually used to determine if the message was actually sent by a good sender. So basically, it's kind of like the authenticity. Make sure that you got it sent by the correct sender. And that's part where we're going to be kind of focusing on when we get to the C code interface. Now, in function blocks, I am not going to go over everything. So this is sort of like a scripting training. We're going to be covering function blocks, but specifically the scripting portion of it. The part I'm going to be covering is really how to automate or how to script. It's not really so much automation. We'll definitely do a little bit of automation within some of the signals, but it's not definitely a full automation. We're definitely not going to be covering that. Function blocks do cover scripting, capture, and playback. Scripting is where we're going to be focusing, where we kind of write our script or write our code. Capture would be something that you would use to capture data. So playback is a fantastic way to capture data on the vehicle. Take that data and play it back maybe on the bench where you might have extra tooling. Function blocks can do run independently of each other. For today's purpose, I'm going to be creating two function blocks for two different messaging because they do have different needs. And they do have different things that we're going to be doing with them. So since we're going to be covering scripting, these are the functions or the commands that you can use in scripting. Now, I'm not going to cover these. I'm going to let you read them. You can always pause the video and kind of read them. The pieces that I'm going to be using are going to be like if statements and ifs, which are really kind of together. We're going to be using jump tos to be able to jump to different pieces of code. In other words, to help us avoid pieces of code. So if we're initializing something, we can go ahead and avoid that, so we don't reinitialize over and over. We're going to be using set values, which is a way to set values for the signals that we're going to be using. We're going to be using also transmit. Transmit is a way to transmit a message. So part of our simulation is going to be using that. And we're also going to be using wait for to cause delays. Because sometimes we don't want to send things too quickly, or we want to make sure that they don't run through scripts too quickly or faster than we actually need them. Since I'm going to be covering graphical panels, I'm really going to focus on a couple of things. So I'm not going to cover this. I do have a separate video that goes over how to use graphical panels or how to create real basics. We're going to create that as part of this, and then I'm going to show you how to create a graphic to kind of do a little bit more advanced. But it's just a really small portion because I think it'd be kind of cool to show you, kind of show you that. I like graphical panels. Things that we're going to cover are not going to be as advanced as what I'm showing you here for graphical panels or what you could create. Some of the graphical panels, some of it takes time, but sometimes there's a way to kind of really emphasize maybe some of the functionality that you want to show. And then the last piece I'm going to cover is when I go over the C code interface, I'm going to show you how to implement this specific checksum. It's a real generic checksum that I came up with. I thought about how to do this last night, and I thought I would share how to create something real simple. Though this isn't, checksums tend to be a little bit more complicated because you generally don't want to see a checksum of 0. This will definitely yield a checksum value of 0. But I just want to show you the process, how to do this. The equation that you do or that you have to implement might be very different than this. But the idea is generally when we do checksums, we create we calculate the entire payload based on bytes, add them all up, and then we send that on the bus as part of the authenticity or to verify the sender itself, not just the data, right, which is part of the CRC of the frame or the message or the packet, but this is really something that goes part of the payload to, again, verify the authenticity of the data itself, meaning did the right sender send it. Let's go and begin by opening up Vehicle Spy. So I'm going to start off by showing you how to configure the hardware, though in reality, to do what I'm going to show you, you actually don't need to have hardware to begin with. I can do this all 100% in simulation, and then of course I can take this and actual hardware and then actually make sure that it actually works with the actual modules. But in reality, to start with, we don't actually need this. But to configure our hardware, I'm going to go on by opening up Vehicle Spy to the logon window, and I'm going to click this button that says Configure Hardware. From here, a window will open up that is called Neovi Explorer. So here I'm going to select my device, click on Connect, and then you'll see on my mouse, whenever I click left click, you're going to see a yellow button. Whenever I right click, you're going to see a dark blue or purple dot. So here, when I open up my device, it goes up to this window, and we see that there is a red. Red generally means is kind of bad. Not always, but it could be bad. So up here where it says Z chip and S chip, if it's red, that means the firmware on our device is different than the version that's on our PC. So in that case, if it is coming up that way, we might want to click manual reflash. In this case, the red down here, it's saying that the real-time clock is off by some offset. Being off by a couple of seconds is okay. Even a couple of minutes, I would say still okay. However, you see off by a couple of years, that means the real-time clock battery or the battery on the device is dead. When we're simulating stuff, when we're just kind of working to monitor, that is okay. The battery being dead might be a real big problem when we're doing data logging, specifically standalone logging, meaning where we disconnect the piece, we program the device to kind of capture data without the PC. And the reason that would be a problem is that because when it wakes up, it'll think it's specific year, and when it goes back to sleep and it wakes up again, it'll think it's back again to that same original time. And so it'll start overwriting data. But if it's just, we're just kind of simulating, again, we're not capturing data, it should be okay. So in this case, I'm just going to synchronize the clock. When we go online, usually this will happen if it happens to be drifting. It's something that happens normally on embedded devices. So here, I'm using a Red 2, so it's going to have 8 CAN channels, at least a specific one that I have. We do have other Red 2 versions that have 2 CAN channels, some that have 4 channels. The one I'm using happens to have 8 channels. So here, if I click on my first CAN bus, I can see the settings for this specific bus. So here I can see that it's set up to be 500K for regular CAN. And then for CAN-FD, it's set up to be 2 megabits. If I need this to be 500K for the CAN-FD portion of it, I can just simply select that option. Or if I need it to be a little bit faster, I can always go to the appropriate option here. In this case, 2 megabits is exactly what I need. If you're working with just CAN, you do not need to disable the CAN portion of it. It will work perfectly fine as long as you are not sending CANFD messages on a system that is just CAN. It will work perfectly fine. If you're working with LIN, you go to the appropriate LIN channel and set up the baud rate. In this case, if I had a Gigastar, for example, or a Galaxy, I could go into the Ethernet channels and change those to the appropriate baud rate or change on what they're going to be. In this case, all I'm going to do is CAN. In this case, I also need to turn on CAN termination here. So CAN termination adds 120 ohms for CAN. My other device is adding 120 ohms, and therefore I need to add this as part of my system. I don't have real ECU, so I'm doing simulation here. Once you make your changes, once you're happy with what you need, click on Write Settings to write those changes. Otherwise, the changes you made will not be saved, and you'll need to go back and make them again. Sometimes, when I'm trying to help someone debug issues, sometimes they'll tell me their device was broken because someone else used it. Generally, what I do, I don't actually sit down and look at through every setting because that could take half hour easily. And so if you ever run into that issue where you lend something to a coworker and it doesn't come back working, the first thing I'm going to say, load default settings. So everything goes back to its original settings. And then I usually just go back and fix whatever I need to fix. So in my case, I just got to fix the termination, write settings, and generally this will get people up and running. Because sometimes there'll be a weird click, option that's buried somewhere, and instead of trying to figure out exactly what changed, it's easier just to kind of go back to defaults and start over. So here now that I made my change, I should write settings, and then I can see at the bottom that it's set, and I can simply just close this window. So the next part is how do we create a setup from the beginning? So I'm going to go to File and Logon. And here I'm going to create a logon name, and I'm going to click plus. Now this is going to create a folder within my directory. Now the folder name that you give it will be, depending on what you're working on. My recommendation is always be specific on what you're working with. That way you remember what you're doing. Not necessarily today, tomorrow, but maybe 6 months from now, when you might have to go back and look at it again. That way you know exactly what you did. So in this case, if I'm working on, let's say, module 24, I'm going to put module 24. If I'm working with a specific ECU, I might put the ECU name. If I'm working with a specific subsystem or a specific domain, I might put that as part of my name. Again, it depends on what you're doing. So here I'm just working with a generic ECU. So I'm going to put ECU, and I'm going to click OK. And this will just simply create a folder in my directory. So if I go to the button on the top right of my vehicle spy, if I click on data, this is where it's going to create a folder for me. So here they created this folder, which is module 25, module 24 ECU. And here I can put in my files that I'm going to be using to create my simulation. So here, if I go back to my desktop, I can drag in the file I'm going to be using, which is this DBC file. And that will be part of my files that I'm going to gather. Now, depending on how you work, you can create multiple folders in different locations. For however you decide to organize, I find it easier just to create one folder and put in all my files in one location. So again, in the future, I don't have to go figure out what I did. It just makes life so much simpler. But again, that is up to you how you organize that. So I'm going to go back to Vehicle Spy here. And now that I've created a folder, I can go ahead and begin to create my platform. A platform is a file that's separate from your setup that references a database or databases. Here, I'm going to click this yellow barrel button, or the button with a yellow barrel, to get me to the location where I can create a platform. On the top right corner where it says platform, we can see a setup platform button. I'm going to click on that to open up this dialog. And then from here, I'm going to click add to open up another dialog window where I can add the platform. And here, usually I'm going to call it the same name that I gave my original folder name. They don't have to be the same name. They can be completely different. But this is just my naming convention that I keep consistently across the board so I remember what I did, because I will not remember sometimes in a week. So I'm going to click OK. And then from here, I'm going to click OK. If I happen to click close, the platform will not be automatically selected for me. I can go back and select it. However, I'm going to be lazy because I want to get to this faster when I'm working. So I'm just going to click OK. And we can see that it automatically selects my platform that I just created. Now here, when we're working with DBCs, normally you're going to find the physical bus or the channel that you're going to work with, and then you add the database. I don't have an ARXML for this, but in ARXMLs, we would click this button, and then we would select the ARXML. Now, when we do ARXMLs, it's sort of backwards. We select the database first, and it'll create a couple of clusters, which are essentially databases for different buses or different networks. And then from there, you physically select the physical buses you want to map it to. So you start with a database, and then you map the bus. So I'm going to go back to my networks. I'm going to select CAN1. And then here in the top right, we have an add button. I'm going to select DBC, but you select the appropriate format you're working with or the specific company. And I'm going to click on DBC, and I'm going to select my file and click open. That will load in my database. I can add more than one database here if I needed to this one channel. But if I have other channels I want to work with, I select the appropriate channels and keep adding databases till I'm done. Here I'm seeing a couple red boxes that are flashing with a red box around them. Vehicle Spy is telling me that I made a change to a platform and that I made a change, and maybe I should save it, click on it so I can save the change. This will save it, but also finish the importing process on top of that. So here now, if I go to Spy Networks, I'm going to go to Messages Editor. And here we can see that I have automatically selected this. Vehicle Spy automatically selects the first channel, which will always be DWCAN01, no matter what. And if I'm working with something different, so if I'm working with CAN2, DWCAN2, I would select that, appropriately. If I'm working with LIN, I can go down to LIN and select the appropriate channel. If I'm working with Ethernet, I can go down to the appropriate channel and select that channel. But in this case, I happen to be working with DWCAN. And then from here, we have a couple of buttons. I'm going to click on Database. Now, Database is the file that I just imported. So I should be able to see the messages that I just imported. In this case, I just have two. Normally, you see a lot more than two, at least for CAN. And then here we have a couple other buttons that's receive and transmit. These two buttons are from the perspective of Vehicle Spy, meaning is Vehicle Spy transmitting the data or is Vehicle Spy receiving? So for things I'm going to be simulating, I'm going to move copying them over to transmit. So if I was just going to decode, this is all I would need to do. I can go online and decode data. But in this case, I am not decoding this data. I'm actually going to simulate this. So what I'm going to do is I'm going to right-click on the signal, and then I can right-click and then copy to transmit. Or what I can do is if I have multiple messages, select the first message, select the last one that I'm going to select. So if it's a much larger list, I can select multiples. Then I can right-click, copy to transmit. So here, if I go to my transmit table, I can see that these two messages are now in my transmit table. So here now I can begin the part to start simulating. So to start simulating, there's a couple of ways to do this. We can do this to the transmit panel, but I'm actually going to use this with a function block. And that's because I'm actually going to add more complex behavior to this in order to simulate these signals within these messages. So in my engine information, I'll see that I have battery voltage, I have coolant temperature, throttle position, I have a counter, and then I have a checksum. Counters are fairly normal nowadays to see a rolling counter to make things a little bit more difficult to kind of figure out what's going on. And also kind of tells you that ECUs are kind of working. Body information I'm going to be doing as well, and that will have the door status for 4 different doors. I'll have a similar counter, and it'll be the checksum. The checksum for these two are going to be identical. There's no difference, at least for my setup. In the real world, generally the checksums might be will be similar. They might add different values to make them different. So, that's just part of keeping things a little bit safer. But in this case, my checksums are going to be identical, which makes life a little bit simpler. But it's not significantly more complex when they're a little bit different. And again, I'll walk you through that when we get to the C code portion of it. So for here to begin with, I'm going to go scripting automation, and I'm going to click on function blocks. From here, there's a plus sign to add different functions, and I'm going to specifically click on script. Here, I'm going to rename my script by double-clicking on the part that says function block 1, and then I'm going to call this engine information. I'm going to click the plus sign to add another script, and then this one I'm going to call this as body information, which is basically the name that's as part of the messages that I work with. Helps if I learn how to spell. So that would be the first part. Now here, there's a start type. By default, Vehicle Spy will give you immediate. What this means is as soon as Vehicle Spy connects, it's going to start running these function blocks. I can do the drop down, and I have a couple of different options I can select from. One of them would be a manual, meaning I want to start the function block manually by either using one of these buttons. The first button that's here, as we can see, there's a button per function block. The first one would be to start the function block. The next one would be to start. The next one is a trigger that's specifically used for capture blocks. And then the other one would be save, and that's also used specifically for saving data on capture blocks. We can also use a start expression, meaning we want to use a condition or conditions to start these function blocks automatically. And embedded only, immediate embedded only is when we want to put these function blocks inside our device. So we can write scripts that in function blocks here and put those into the script into our device using Core Mini, which is basically like a hardware accelerator, and be able to run that independent of our computer. For what I'm going to be using today, that won't be possible. If I was just doing everything in function blocks, that would be possible. But because I'm adding C code, that makes it much more difficult to do that. So in this case, I'm just going to leave them immediately. So I want these function blocks to run as soon as Vehicle Spy connects. So let's start by working with our engine information. So the first thing I'm going to do is here is where our commands go. So if I double click, will give us a drop-down window. So if you go back to the beginning of the presentation or the video, you'll see the different options and descriptions of what they do. For here, what I'm going to do is I'm going to click on transmit. When we start doing scripts, what I'm going to recommend, especially if you're new to scripting, is add things piece by piece. Don't try and come up with entire logic from scratch and kind of go over the whole thing, because that can be very frustrating. It's very few people that I know that can sit down and write the entire script from scratch and get there maybe 90% of the way or 95% of the way there with still minimal changes at the end. As we go along with this stuff, we add piece by piece. So here to begin with, if I do a transmit here and I select my first message, I want to do engine information, and then I go online. And here, all I have to do is really, I can go and run simulation, no replay file. I don't need hardware again to do this part, at least, not to begin with. To test the final piece, we definitely need hardware. But just to kind of do this on my desk or do this from home, I don't need hardware. So I'm going to click simulation, no replay file. So I'm going to transmit a message, and I'm going to go Spy Networks, and then messages here. And we see we're sending a message, and we see we're going really, really fast. I know this message does not need to go out that fast. So the next piece I'm going to add now is I'm going to stop Vehicle Spy, or I actually don't have to stop Vehicle Spy. I can leave it running. I can go and start changing things on the script, and it'll stop the function block. So I can do wait for. Wait for would be something, maybe I want to slow this down a little bit. So maybe I want this to be running at 500 milliseconds. I can simply click OK now. So now if I click the play button here, it'll start running my script. And I can go to messages and I can see, oh, now it's running at 500 milliseconds. And you can see this, I did this in 2 steps. So I don't have to sit here and do the whole script from scratch. I can always add and mature a script over time. And over time could be over an hour, or it could be over a couple of weeks or over a couple of months. I've had scripts where it took me a year to develop, but that doesn't mean I sat down with a script and developed it, 8 hours a day for a straight year. No, I did maybe an hour today, maybe 2 days from now I did another hour, maybe next day I did 4 hours. And over a course of a year, I matured it as I came up with requirements of what I want my script to do. Automation is sort of the same thing. As we start seeing how things are being used, because sometimes we don't see that from the very beginning, we'll start adding things, over time. So here I have a real simple script now that's sending a message, and it's sending out every 500 milliseconds, and I did that in 2 steps. So here now, what I want to do now is if I go to like Spy Networks and transmit message or TX panel, I can click on the message itself and see what we're sending or what signals we have. And so we have battery voltage, we have coolant temperature and throttle position. So I want to be able to send those messages as well, or those, not those messages, the signals. So to do that, I'm going to go back to function block, and I'm actually going to stop Vehicle Spy this time. And then I'm going to click maybe step 2 or step 3, double click, and I'm going to do set value. From here, I can go into what I'm going to be using, which is transmit panel. I'm going to expand this out to my engine information, and I'm going to double click battery voltage. This will add it to the top line. If I want to just set this battery voltage to, let's say, 12.5 volts, I can type into the expression, click OK. Now, if I go back to my messages view, I'm actually going to drag this to the far left because that way I don't have to think about where it's at. And I'm going to click play. And if I expand this out, I can see that it starts sending the updated value. Now here, from a real basic simulation, this is sufficient. I don't need to do much more than that. But in my simulation, I want to be able to vary this because I want to be able to do this manually, and I want to be able to do this dynamically, meaning I want to be able to change this as I need it. I don't want it to be static. This networks tab, I don't need anymore, so I'm going to close that out. This TX panel at this moment, I don't really need it, but I can close it out if I need to. And then here, I'm going to go back to my function block. And now I can add another signal. I can do another set value, and I can pick the other signals in my engine. So I can do coolant temperature. And then to coolant temperature, I'm going to set to 75 Celsius. And I'm going to do another set value. And then from here, I'm going to do the same thing again. I'm going to go to engine information and do the throttle position. And I'm going to set that to 5%. Click OK. So now if I go back online, which is I'm already am, I'm just going to restart the function block. I can see those values are now being updated. But this is not good enough for me. I want to make sure that I can link this to a graphical panel because I want to be able to change them. So now what I'm going to do is I'm going to go scripting automation, and I'm going to create application signals. I'm going to click on application signals. Application signals are signals that we create that we can use within Vehicle Spy to communicate from one location to a different location. So I'm going to click plus, and I'm going to call this throttle position. I'm going to leave it as analog. This one I'm going to do 0.00 because that's exactly what it's part of the bus. I want that to match that format. Since this is throttle position, this is going to be percentage. So I'm going to put a percent sign. Initial value, I don't have to give it initial value. I like these values because whenever I start Vehicle Spy and I start simulations, I want my simulation to start the same exact way every single time. This is not required. This is more for me. Out of all the years that I've done software, one of the biggest things that I've always had problems with, and not just for myself, I've seen other developers have this problem, is that things are not initialized and things start in different ways. So if I don't give this value, and if I save my setup after I'm done testing, it will save those values, which is fine if that's exactly what you want. I don't like that. I want my system to be the same way today, tomorrow, and 6 from now. I don't want to have to think about what I did 6 months away or ago. And I want it to start the same exact way. So here I'm going to add another signal. And this one I'm going to do a coolant temperature. And I'm going to do the same thing. This one's going to be a different format. So this one's just going to be C. I'm going to do the same format. And I'm going to do a different value of, let's do 75 for this one. And I'm going to do another one here. And this one, what I already forgot to message this, is battery voltage. So here I'm going to name this to be battery voltage. Now these signals don't have to match my actual signals. They can be whatever I want them to be. In this case, I'm just keeping it simple because I want to be able to tell what I did later on. Again, sometimes I will forget things within a couple seconds. And then here I can just do V, or I can say volts, be more descriptive. Initial value here I'm going to do as 12.5. So this kind of gives me signals to be able to communicate from one location to a different location. So now if I go into my function blocks and stop Vehicle Spy, this battery voltage, instead of being hard-coded here, I'm actually going to click on app signals here, and I'm not going to double click because if I double click, this is going to add it to up here. So here what I'm going to do is I'm going to select it, and then I'm going to add to expression here. If I double click, it's going to add it up here, and I don't want that. And then I'm going to click OK. And I'm going to do the same thing with the coolant temperature. I'm going to select. I got to get rid of the hard-coded value, and then add to expression, and then click OK. And I do the same thing with the throttle position. Get rid of the value, select throttle position, add to expression. Keep in mind I've selected here app signals. Click OK. So if I go online, I should be able to see those values that I gave it, which I thought I did 5%. It looks like I did 0, so I want 5. Click somewhere else now. And then I'm going back to messages view. I'm going to stop Vehicle Spy and restart it. And I see that it updates to the values that I give it. Again, this is how I wanted to start this. So next thing now, to how do I link this to a graphical panel? So I'm going to go measurement, graphical panels. So by default, this opens up this way. Here is the name of the graphical panel that will show up at the bottom. Panel form 1 is fine for me, or I can say simulation, it could be that, or it could be powertrain, since some of these values are powertrain, some are body, so I can say it's body, and then I can say body powertrain. And I'll update the name down here at the bottom. The next thing I'm going to do is I'm going to add a slider. So this is this one right here. So this slider will have properties on the right side. If I click on the back panel or the background, it will have properties itself. If I click on this, it'll have properties itself as well. and here says it's bar graph. So if you ever look at some panel that you kind of think that you really like, unlock it, which is locked down at the bottom right here, and then click on the device and see what it is. Sometimes it'll be, well, you will surprise you what it might be. So here, what I'm going to do is I'm going to change the bar color to a different color. Let's go with a yellow for this one. And then here, the signal here is what I'm going to map it over to the first part. So this one, I'm going to map it over to battery voltage. I'm just going to double click and then click OK. The other thing I'm going to do is I'm going to change this from horizontal is perfectly fine. I could change it to vertical if I wanted to. And what I'm going to do this, I'm going to leave this as horizontal. I'm going to change it from bar graph to slider. So instead of being an output, I want it to be an input. And then from here, I'm going to make this a little bit bigger. And then from here, I'm going to add this ADC, which is just sort of a caption. We can also display outputs on this. But here, what I'm going to say here is I'm going to say this is battery voltage. This is too small for me, so I'm going to change the font by going to the font tab. Click on 12, maybe 14. Then I'm going to make this a little bit bigger. And once again, it helps if I spell correctly. Voltage. Okay. So here, if I don't like this caption, I can always go to this cap where it says enable. Nope, it says show caption here, and I would do no, and it will get rid of the middle piece. But in this case, I'm going to leave it on because it gives me the value of the voltage on top of that. Now here that I've mapped it over to a voltage or to a signal, it'll give me a range here. And I don't want this range to be what it says here. So I want this to be from 0 volts, and I want it to be up to 20 volts. How do you pick those values? Will be depending on the range that you have for the signals. In this case, 20 will be sufficient for what I'm going to be doing. And I'm going to make this a little bit smaller. And then I'm going to copy these with my keyboard, Control C, Control V, and then I can just kind of leverage the same work that I just did, especially if I like the sizes. And the next one will be cooling temperature, and then we'll do the throttle position. So this one will be coolant temp. And I'm going to map this one specifically to the signal here, coolant temperature. Double click OK. And the rest is fine. And then the color for this one, oops. I didn't want a signal on this one. I want the signal on this one here. So this one I want to be coolant temperature, double click, it updates the value. And I don't want this to be yellow. Let's go with a orange. And then this one, since it's a coolant temperature, I'm going to start off with 0 degrees, and then though technically it could be negative for temperature. Here I'm going to do 150 maximum. And I'm going to copy this one more time again. And then paste this at the bottom. And then this one's going to be the throttle position. And then the piece down here, we're going to do throttle position, double click OK. And then we're going to change the color in this one to be a different color. Now here I'm going to highlight all these, and I'm going to right click, align, centers. Because I do want these things to be kind of a little bit nice, a little bit straight. So I'm going to move this up a little bit. Fortunately, there's no way to do horizontal automatic, which is fine. And then from here, I'm going to click at the block at the very bottom right, and I'm going to left click on this and hold it, and I'm going to drag to this little box here. So now if I go online now, I should be able to now control these signals here. We can see that they start off by default, and now I can change my throttle position. And my throttle position is a little bit too large on range. That one should be 100%. This one should be okay, and that should be okay. Okay, so now I can see that my throttle position here is going to be changing. And I can change the temperature as well. And I can change the voltage, at will. So I'm doing this from a graphical panel instead of doing it through transmit panel, which makes things a little bit easier. Okay, so here I'm seeing that the values are not updating as fast as I want them to be. So I'm going to change this from 500 to 250. Ideally, you want to use whatever the periodic rate is for the message. And I'm going to restart this again. and I can update these values now. So now I'm going to do the same thing now for the body. So I'm going to stop vehicle spine, and I'm going to do this very similar thing. I'm going to do a transmit. I'm going to click on T, so it gets me there a little bit faster. And this time we're going to click on the body message. So I can transmit that, and I'm also going to do a wait for timer again. And this one I'm going to do also 250. And then here, what I'm going to do here is I'm going to do a set, type in S, and then from here, I'm going to go to the TX messages, body, and I'm going to do the front door. I can start by doing 0, which is closed in this case. And I can keep doing this to the other, keep adding the other ones as well. So now I'm going to do front right, 0 here for close for now. Set value. We're going to do left door. Here, what I'm doing here is I'm actually going to here, and I'm actually doing deep to filter, and it'll expand this out for me, which makes it a little bit faster than 0. And then I'm going to go back to application signals and do this, a very similar thing at new signals here. And then this one, I'm going to do front left door status. And I'm going to do a format of digital. True false should be fine. I can also do closed open. And initial value is 0. And this time, instead of recreating all this, because they're all going to be similar, I'm going to do this copy, paste. So now I have this where I can do this now to front left, front right, rear left, rear right. So I can go a little bit faster on that. And now here are my doors. I can go into the app signals. And in this case, I'm going to get rid of this one, the value. And this is front left. I'm going to click on it one time, add to expression. And then this one's going to be delete the same value or the expression value. Front right, add to expression. And then here for this other one, I'm going to double click again, get rid of the 0. This one's rear left, add to expression. Same thing here, but this one's going to be the right rear, add to expression. Click OK. Okay, so now that I have this, I'm actually going to go in and create a picture of a car. I'm going to open up I'm going to open up PowerPoint for this. So for this, I'm actually going to insert a new slide. I'm going to do one without anything on it. And the first thing I'm going to do is I'm going to draw a box. So I'm going to format my shape. I'm going to pick a different color. So the purple. And then I'm going to get rid of the line around it. And then I'm going to draw another box here. I'm going to do insert a box with rounded corners, which will essentially be my car. Oops, actually I meant this one to be purple one. And then the back one, what I want to do is I want to do a gray like Vehicle Spy has. So here I'm actually going to increase the color of this one, or the border. Center that off. And then from here, what I'm going to do is I'm going to attempt to make windows. So make that a white. Copy and paste it so I can do the rear window. And paste it again. This time I'm going to do it for the side doors. Okay, so that gives me a real basic car. Now I'm going to go ahead and copy this over to with Share X, which is what I'm using to copy, do screenshots. And then from here, what I can do now is I can open up Paint, and then I can go ahead and paste it. So here I can do Save As and Bitmap. So Bitmap is what you'll need to import into Vehicle Spy. So that gives me the car itself. So now I can go back to this one, and I'm going to actually leverage these doors that I have created. And I'm going to create a new slide. And then from here, what I'm going to do is I'm going to insert a box, well, another box. And then this one will be the color of the vehicle spine, no line. And then from here, what I'm going to do is I'm going to copy this little door, this window, which I'm going to make into a door. Now this, I'm going to actually change the position of it so it looks like it's open. So I'm going to change this to a 45. Oops. And then I want this to be color of that purple. So here I'm going to try and resize this box here. So I don't want this to be bigger than I need it to be. Because it looks like all that stuff is now sorted. And hopefully I got a good picture here. So I'm going to go ahead and screenshot it. And then what I'm going to do now is I'm going to go back to Paint. I'm going to paste that. Okay, so now here I can go ahead and do this file save as. And that's going to be right door. Go back to PowerPoint. And then this one's going to be, I think it's 135. Yep, great. And I'm going to do something. I'm going to screenshot it. Go back to Paint. And then this is going to be left door. And then I got to do one more screenshot. And I'm going to move the purple part out of the way, because I want it to be when the doors are closed, not to show up anything. So back to Paint, paste, file save as, bitmap, door. So at this point, I can probably close this out. No longer need this. And now I can go back to vehicle spine now. Move this window down a little bit. And then here I'm going to unlock this. And then here I'm going to make this a little bit bigger. And I'm going to use this picture one, which is this one right here. And then I'm going to add my vehicle. So from here, I'm going to click on the vehicle itself. Click OK. Make this window a little bit bigger. And I'm going to get this sunken border to none. And we can see the background blends in really nicely. From here, now I'm going to do a bitmap button, which is this one right here. And then this one, I'm going to click on image. And I'm going to add door closed first. And then I'm going to add door closed again. It's just the way I need to do with vehicle spine. And then I'm going to do left door open. Then click close. Now this one, now I'm going to click on the signal here. And I'm going to map this over to the front left door. Double click, click OK. So now here I'm going to put this over here on the left side. Lock this window and see what vehicle spy does. So now here I'm going to open up body information. I'm going to click on this. And I see that I made a mistake already. And I need to change this from push button to toggle. Lock this down. And we can see that this now, it looks like it's open and it's closed. So now I'm going to make this a little bit closer because I don't want it to be that far off. So I'm going to have to add a button again and do the same thing. So it's going to be rear left. Images, I'm going to do the same thing. Door closed for the first two options. Trying to click really faster and I'm actually making more errors. And then this one's going to be toggle. Image is done. Rear left is okay. And let's see what that looks like. So we can see that it's open now for those two. But now that it's in this image, I can always go back and kind of adjust this if I don't like the way it looks. And then now I can add two more for the other side. So I can do the same thing, toggle, and I'm going to add the closed door twice. And then this one, we want the right door. And then this one we're going to do signal front right door. I'm going to do another button here. I'm going to change that to toggle, image, plus. This one would be right rear. So I think same thing. I'm going to use my keyboard here to put them in the position that I want. So now I have different graphic that kind of looks like a car, right? It's not exactly a car, but here I can now use these as buttons to kind of open and close the door. So here I can control my simulation, but have a graphic that looks kind of I don't know, I kind of like it, even though it doesn't exactly look like a car. It's good enough. So here now we have ways to kind of do all these things. So now we need to do counters. So here now in my simulation, I'm going to move this over to this window to the right, so I have a little bit more space. And now we're going to start adding a little bit more complex options. So first we were doing kind of real simple signals, and now we're going to do more complex stuff. So I'm going to move this over to the right, and then I'm going to go back to function blocks, and I'm going to start with going engine information. So for this one, I'm going to stop Vehicle Spy. I'm going to add before. So this is a way to add more lines to this. So based on where you select, you can add lines before or after. So I can just add a bunch of them. So here I'm going to do is I'm going to do a set value. And in this one, I'm going to do the transmit message. And I'm going to do the start on engine. So I'm going to select the counter. And I'm going to add, I double click to add it to the top. And I'm also going to click to add to expression. And I'm going to do +1 because I want this to increment. I'm also going to copy this line. I can also copy lines by controlling Control C with my keyboard, or I can right click and then I can copy and paste. But in this case, I'm going to use my keyboard. And here, what I'm going to do here is I'm going to actually set to 0. I want my rolling count or my counter to always start at 0. And then from here, I'm going to change it over here. So this one now, what I need to do at the very bottom here is I'm going to do a jump to statement because I don't want to reinitialize at 1 again. I want to make sure I start at line 3. So this will basically what I'm saying is I want to initialize this value to 0, set these values to whatever my graphical panel set to. From here, increment this counter from whatever it is to a new value. So if it's 0 to begin with, it equals to itself, which is 0, and then you increment by 1. Here I don't want, because I'm only doing 4 bits, I can't be above a value of 15. So what I'm going to do here is I'm going to do a if statement by typing I, get to the if statement. And then from here, I'm going to go into my counters here. I'm going to type in C for engine for counter. And then here I'm going to say whenever this is greater than 15, I want to set it back to 0. So I'm going to copy this line from above, and I'm going to do an end if. Anytime you do an if statement, it has to have an end if. So this is going to basically see whenever this value goes above 15, it's going to reset it back to 0, and then we start the counter once again. So here now I'm going to start simulation again. And now we can see that it starts to increment the value. 15, it seems to roll over. If I want to double check, I can always do a scroll. And I can click on pause to see what the value is. So here's, I see a value of counter 15. And it looks like it might be going a little prematurely. We'll go up to a different value. Oops. Helps if I put the right value here. Down here, I'm going to change this over to CanFD. I'm going to do message 1, 2, 3. Trace. Do this again. Okay, so I can see that it's 14, 15. So that's working properly now. Okay, so I'm going to do the same thing now with the other function block. So I'm going to do a set value. I'm going to go to my TX. I'm going to do counter, but this time it's going to be for the body. And this one's going to be set to 0. Same thing as before. Put a line after, and this one's also going to do a jump to. And this one's also going to do to step 3. And then just like before, I'm going to do an if statement. So I'm going to do if, type in I. And then whenever I'm going to do the counter again for the body counter, whenever this is above 15, I want to set this back to 0. So I'm going to copy the first line and if. And this should also be doing the same thing as the other one, yeah. If I did it correctly. It doesn't look like it's counting. Oh, it helps if I have the logic to count. So here I'm going to copy this line one more time. Oh, by the way, if you select the line that you don't want, just click the minus and it'll go away. So here now I need to set it back to itself. I'll get rid of this 0. This is body, so it's going to be plus and then +1 and OK. Okay, so these values are counting now. Looks like it's rolling over at 15, so that's exactly what we need. So this concludes the basic portion of it. So now we're going to do the hard part, which is the C code interface. And it's hard because if you've never done this, this can be quite challenging. In order to do the C code interface, you do need to have Visual Studio. You should be able to download a free version. Depending on the company policy, you might not be able to download for free. You might need to purchase it, but you will need Visual Studio. So here I'm going to go Script and Automation, and I'm going to click on C code interface. I'm going to move this window over here. And from here, what I'm going to do is I'm going to click on Add Project, and then New. So I'm going to rename this to be CRC Simulation. And usually I copy and paste the same description. You don't really do it, and then click OK. So Vehicle Spy will actually create the framework for you. And then from here, I'm going to give this OK. For this options up here, I want to do release, and then I want to make sure I select Win32. So to begin with, the very first thing I'm always going to do is I'm going to go build, and I'm going to build a solution. Now I want to make sure that this builds and actually works. And the way we're going to make sure that it works is we're going to go back online. And again, this doesn't have to be connected to hardware to know if it works. This will move over to this output window. So the setup and output. And if you see this running, it means that you built successfully. That means it's built correctly. With Vehicle Spy being Windows 32-bit still, this is why you need to select 32. If you select 64, it will not work. So keep that in mind. So here now I'm going to go back to Vehicle Spy, and I'm going to stop Vehicle Spy. Then I'm going to click on the Setup tab. And here what I need to do here is I need to click on Edit. So here in Messages, I want to click on TX for the messages I want to transmit. So I'm going to double click to add it to this list, because I'm actually going to be transmitting these from C code instead of the function block. I'm not going to change the function blocks at this point. The function blocks are exactly what I needed to do. By having that transmit in there, I actually call the C code. So I don't need to do anything else. And then it'll actually call the part that I need for the checksum. And then from here, if we go to this event handler, we'll actually get code. I want to copy this. And I can simply click this copy button, and it'll copy the code. And I'm going to click OK. At this point, this part is done from this perspective. I don't need to do anything else in this window. So here I'm going to go back to Visual Studio. I'm going to expand this out. And the code that I want is the Spice C code. And at the very bottom of this, I'm going to go add a space and copy the code that I just added. Now, these ones right here, I am not going to be using. The ones that I'm going to be using are the ones that say return. Those are the ones that are actually going to return the values that I need. The other one that you need will be this vspy.header. And this is where you're going to find the functions that you're going to be using. So from that perspective, that's all you really need to do. So for this one, I'm going to start by searching for this string. This is tx can1. I'm going to copy that. I'm going to go vspy h for the header. I'm going to search for that. So here is we're going to be using this specific piece to add our checksum. But here what I'm looking for is what is the name of this message that does transmit. We'll see one that says raw and one that says transmit. So I specifically want to do the one that says just transmit. I'm going to copy that, go back to my C code, and I'm going to go into this one, and I'm going to put a couple of returns. And I'm going to put this to the transmit, put parentheses, and then I'm going to do a colon after it at the end. And I'm going to copy this pointer, and I'm going to put this as part of this. So this is actually going to do the transmit portion of it. The other part that I want from this one is this one that says update bytes from signals. So I'm going to copy that, and then I'm going to do the exact same thing, but I'm going to put this before the transmit. Same thing, parentheses, colon. I'm going to copy that same variable for the pointer, and I'm going to copy that. So what this is going to do is it's basically going to update all the bytes from your function block, and then it's going to transmit them. This one's kind of important because we're going to leverage this to do the checksum. So we want to make sure that we update our bytes. So next part we're going to do is we're going to copy this portion again, which is our checksum. We're going to do dot, and then we're going to do checksum. Now this is actually going to add the little arrow. And then from here, I'm going to do equals to, and I'm going to paste the same one again, this initial value. I'm going to do dot, and I'm going to do message data dot b byte. And then here I'm going to do brackets, square brackets, and I'm going to do 0. So this is my byte 0. So now I'm going to copy this part here, and I'm going to do a space plus this one, byte 1. I'm going to do a carriage return plus, and I'm basically going to keep adding all the bytes that I need to add to duplicate the equation that I gave you at the very beginning, or the polynomial that I gave you at the very beginning. So here's 3. I'm going to do return plus, and I'm going to do this one's data byte 4. And then here I'm going to just maybe make it a little bit faster. So this one's going to be 4, 5, 6. So we start, so there's in the equation it shows you 7 bytes. So in this case it starts at 0. So 1, 2, 4, 5, 6, 7. So that's really all I need. And then because if I go back to the definition of the well, if I go back really to the presentation, I see that I need to do a shift of byte 7 over byte 3 bits. The reason we need to do that, well, as part of the equation, is if I go to the messages editor, we see, at least in this one here, that the byte 7 holds a counter. But part of the checksum goes into the byte 7. We don't want to include this piece into our checksum. So by shifting this over by 3, which is really what by 3 bits, we're getting rid of this portion of it. So that's why we're doing that piece. So I can go back to this one, and then here I can just do a shift, which is by 3, which just looks like that, and then a semicolon. So if I did everything correctly, this should now calculate my checksum. So all I have to do now is go back to build solution. As long as I don't see any issues here, I see it succeeded. I should be able to go back to online with Vehicle Spy and see a checksum being calculated here. I only did one, so we see that checksum being calculated now. So if I change things like doors, that checksum should also change. So now to do the other one, I'm going to go back to Visual Studio. And here, I'm going to do a very similar option here. One thing I also need to do is I need to change this from 0 to 1, because I want this to win and not the function block. So here I do need to stop Vehicle Spy to rebuild the solution. So now I can rebuild this again. This one is extremely important to make this work properly. And that looks actually a little bit better. And that's exactly what I expect to see now. So now to do the other one, I'm basically going to copy this entire code. So here I'm going to copy this, literally the entire code, to the next one. And then I'm going to go back and change and find out what this should be now, which is this engine one. So if I go back to this header one, I should be able to go find, nope, that's not the one. So here is the engine, which is a transmit. I don't want the wire, I want the rotary transmit. And I'm going to replace that with a transmit over here. And I'm going to do the update bytes from signals. I'm going to do that up here. Now this one here is, we want to use this specific one, so we got to replace all these ones here. Now I could go into another editor, like a text editor, and change this, but I can do, a replace there. So here I have updated all the code. Make sure Vehicle Spy is not running. Everything looks okay now. If I build this correctly, or if this builds correctly, I don't have any error issues. So if I accidentally left a value here, it should tell me. It looks like everything built. So now if I go back to Vehicle Spy now, I can see checksums are calculated for both. If I put these values to 0 on the engine one, I should see a value of checksum of 0, which it does. And so now this is working properly now. So now I should be able to go in here and change, turn on the doors. I should be able to see that clearly. I can, stop this again so I can get these values to go back to the original value. As I'm doing this also, what I could do, if I want to see the values as they're happening, instead of being in messages view, I can go in here and add a grid. And here I'm going to go into signal groups, TX values, and I'm going to expand these out. And I'm going to add the doors, battery, temperature, and throttle position. Click OK. So here I'm going to make this a little bit bigger. I'm going to align to the left. So here, what I could do now is I can move this window over down here if I wanted to. I can use this to align the centers now. I want to make this a little bit smaller. I think 155 works. Maybe 156. There we go. And now I can make this move over a little bit. Now, if I wanted a little bit more contrast, of course, I can go into the background, click on the background, and I can change the color if I wanted to. So that gives you obviously a different look. So now I can go in here and look this. So here, if I unlock this, if I left click and hold my graphical panel, I don't even need to go into my other window. I can see everything that's happening here. I can look at it from here. So I don't even need to go anymore to my messages here. But of course, if you want to, again, you can, it's just a matter of rearranging some windows, and now you have it. So this gives me a full simulation using function blocks, C code usage. Hopefully that gives you enough information to kind of play around with stuff. Once you're done, make sure that you save. Actually, if anything, you probably should save more frequently in case you have any software issues or PC issues. That way you're not losing your work. And so to save, you want to go to File, Save As. VS3-zip is usually what you want to select. And then just click Save. So that will save off your basic setup. Now, if you're going to share with somebody else, that's not how you want to save this. What you want to do is you want to go back to Files. You want to go File, Save As again. And then here you definitely want to use it. You can use the same name. You don't have to use a different name. It looks like I misspelled my own name here. And then we want to select VS3-zip. So VS3-zip will contain everything that you need, including the DLL, any databases that you imported, or database will include all of that in one location. And that's what you would use to email to somebody or share, however you share with other team members, whether it's a simulation file, whether it's an email or some other method, some repository. That's what you would email or send out. So this is good for my computer, but if I need to share with anybody, this is what I want to send out, the VS3-zip. The other thing, by default, you shouldn't have to do this, but just in case, when you're in the C code interface, there's this little box that says Save DLL to VS3. Make sure that remains checked. Otherwise, if you send this off to anybody else, it will not be part of that setup. By default, it is checked, but again, just don't uncheck it. And then the final piece here is if you want to learn a few more things, I do have a video on how to create graphical panels. So it's a little bit of what I kind of showed you, but it has different graphics. If you happen to have Vehicle Spy Enterprise, I do have a video or 2 videos on Gateway Builder. So if you need to do any kind of CAN fault injection or LIN fault injection, I have videos on that. If you want to learn about 10BASE-T1S, I have a separate video for that as well. The first 25 minutes covers the basics of automotive Ethernet or an introduction to automotive Ethernet, and it gets you, a little bit more knowledgeable on 10BASE-T1S if you're going to be using that. If you have any questions, you can always contact our technical support team. You can always send out an email to sales. That way we can get you in contact with the appropriate person. On that, thank you so much for watching.